In this video, we're going to work through the last page of the ACT. This is problems 55 through 60, so the last 6 problems. And you'd think with this being the very end of the test that these would be the most difficult problems on the test. And some of these are kind of challenging, but I think you'll see that these definitely aren't the most challenging problems on the test. So when you're taking the test, don't psych yourself out. That said, these problems will probably take a bit longer than normal, so it's okay if it takes a little bit longer than a minute per problem. Still, give yourself some kind of time constraint when you're practicing these problems, and that will help you with the test anxiety and the feelings of being under a time constraint on the test. Alright, so let's dive in. Problem 55 says, if I equals the square root of -1, then I plus I squared plus I cubed over I cubed plus I to the 4th plus I to the 5th equals what? So first, with a problem like this, it can be just kind of intimidating right off the bat. They're talking about I, and you may not have even learned about I in class. If you have, you should know that I is the square root of -1, so this isn't new information, but maybe you've never learned about this before. But the ACT is still going to give you problems where you should be able to figure out the answer based on the information they provide you, just by logically working through the problem. This one's a little tougher, and it's going to take some time to work through, but let's just try to make sense of like individual pieces of this fraction. It starts out with I, which they told me is the square root of -1, and I'm not sure if I'm supposed to do anything with I there, but I'm just going to write the square root of -1 because that's all I know. And then it says plus I squared, so let's figure out what I squared is. Well, I is the square root of -1, and if I take that and square it, the squared and the square root cancel each other out, and I'm left with just -1. So I squared equals -1. So here I could put a -1, and then they're saying I cubed, so let's figure out what I cubed is. All right, well, I cubed, I could think of that as, it's just I times I times I, or in other words, I squared times one more I. The reason I'm using this is because we just figured out what I squared is. I squared is -1, and then there's just times one more I. So this is just negative I. I'm just going to write it this way so it's a little bit simpler. I cubed is negative I. So I could write negative I here. And I guess over here, instead of writing I wrote square root of -1. I'm actually going to just change that back to I, because then these are like terms. So when I'm writing out my work, I want to try to combine things as much as possible, so I'm aiming for having like terms whenever possible. Alright, then big fraction bar, and then there's another I cubed, and we just figured out what that is. It's negative I. And then there's I to the 4th. Well, I to the 4th, I could think of that as I cubed times another I, just like I did before, kind of. Or I could think of it as I squared times I squared. Either one is fine. I'm going to think of it this way though, just because that's -1 times another -1. We figured out I squared up here. And -1 times -1 is +1. So I to the 4th is +1. And again, if you're not familiar with I, if you haven't learned it in class, all of this might seem really weird. And even if you have learned about this in class, these kind of properties of I definitely do seem kind of weird. But let's just substitute this value in and keep going with what we're doing here. So the last one is I to the 5th, and I'll keep the same pattern of thinking going. So I to the 5th is I to the 4th times one more I. And we know I to the 4th is 1, so I to the 5th power is just 1I. Or in other words, I to the 5th power is the same thing as just regular I. So then this is plus I at the end. Now looking through this fraction, it's almost so simple that it looks confusing. The first thing I'm going to do to simplify this a little bit is I notice I have this plus -1, and it's kind of silly to say plus -1. That's the same thing as just -1. So let's get rid of that plus. That makes it a little bit cleaner. I also know that I have this positive I and this negative I on top. So in other words, I minus I, those just go away. So the only thing left on top of this fraction is a -1. And then on the bottom, it's the same thing happening. We have a positive I and a negative I, and when you add those together, they cancel out or they become 0. So on bottom, we just have 1. So after all of that, we just end up with a fraction which is -1 divided by 1, which is -1. Number 56 says, in one of the following graphs in the standard xy coordinate plane, the solution set to the system of inequalities below is shown shaded. Which one? So in classic ACT style, this problem is worded very formally, but it's really just saying match the graph with this system. Now it is a system of inequalities because we have these less than or equal to or greater than signs. And so that's why all of these graphs have shading, because we're dealing with inequalities. Now every one of these options for graphs has a circle and a line. So one of these must be the circle, one of them must be the line. And maybe you have learned about graphing circles and lines in class, maybe you haven't, but regardless, you should be able to make an educated guess. This bottom equation, or inequality, has squareds. It has an x squared and a y squared, and that's kind of weird. I've never seen an equation with a line with squareds in it. So this bottom one must be the circle, and the top one must be the line. If we take this inequality for the line x plus 2y is less than or equal to 6, I'm going to put that over here, but I'm going to say x plus 2y equals 6. And one way you can think about graphing lines in this form, which is different from y equals mx plus b form, which you may be more familiar with, is just think about what happens when you plug in 0 for x, and this is going to help us find the y-intercept. So if I plug 0 in for x, this becomes 0, basically just goes away, and now I have this equation, 2y equals 6, and I have to solve for y. So I would divide both sides by 2, and I would get that y equals 3. And I could do the same thing for plugging in 0 for y. So if I plug 0 in here for the y value, 2 times 0 is 0, this all just goes away, and so now I have this equation, x equals 6. There's nothing to do there, it just equals 6. So here's my x-intercept and my y-intercept. On a graph, that would look something like this, 0, 3, and 6, 0. Looking back at the inequality, this one has an equal to bar underneath, so it should be a solid line. And so I can rule out j. You can tell that we shouldn't have a line with a positive slope, ours has a negative slope. The next thing we could test is what happens if I plug in 0 for x and 0 for y. What I'm doing is I'm looking at this point at the origin, 0, 0, and I want to see if that makes this inequality true or false. So 0 plus 0 is 0, all that goes away. Is 0 less than or equal to 6? Yeah, it is. That's true. So that means I should shade that side. So everything below the line gets shaded. And so that helps us rule out h. Let's move on to the circle for a little bit. So you may not be very familiar with equations or inequalities of circles, but we can still do the same test where I'm going to plug in 0 for x, so 3 times 0 squared is greater than 12 minus 3 times 0 squared. So plugging in 0 for x and y, so I'm looking at the origin, and I want to see if this is true or not. So 3 times 0 squared is all just 0, greater than, and then 12 minus 3 times 0, all that is 0 again. So is 0 greater than 12? No, 0 is not greater than 12. That's false. So that means that on these graphs, I do not want to shade the inside of the circle because the circle's out here, and we just looked at the point 0, 0, and we found that's false. So don't shade inside the circle, shade outside the circle. And that means I can rule out G. So if we compare these last two graphs, F and K, it looks like the line is the same. They're both solid lines. They're both shaded below the line. So it comes down to how big is the circle. Is the circle here and it doesn't intersect the line, or is the circle bigger and it does intersect the line like that? All right, so let's take a look at 3x squared greater than 12 minus 3y squared. The first thing I'm going to do is take this y squared term and move it over here on this side of the equation. So 3x squared plus 3y squared is greater than 12. And then we might as well divide everything by 3. As long as we divide the entire equation left and right by 3, we'll keep it balanced. So now I have x squared plus y squared equals 4. Actually, it's greater than 4. And so this is relying on you knowing a little bit about the equation of circles. Okay, we want them to look like x squared plus y squared. That's kind of like the classic form for the equation of a circle. And then on this side is r squared, or the radius squared. So if the radius squared equals 4, if I were to take the square root of that, that must mean that the radius is 2. So we have a circle centered at the origin. The radius is 2, so it's kind of small. Matter of fact, it's below this y-intercept up here. And so after all of that, the answer must be k. 57 says, let a, b, c, and d be real numbers. Given that a times c equals 1, b plus c over d is undefined, and a times b times c equals d, which of the following must be true? In a problem like this, where they're giving you all of these really generic statements or seemingly generic statements, it's really easy to kind of just like gloss over that and then be confused. And then you look at the answers and you're like, well, I don't know what to do with this either. Some people might try plugging these values into some of these equations, but then what do you really do with that? What are you trying to do? What is your goal? So I would recommend, let's try to make as much sense as we can from these statements that they're telling us, because they're not just telling us nothing. If they say a times c equals 1, what does that tell us about the values of a and c? Let's just think about some examples, like what times what equals 1? What about like 2 times 1/2? That equals 1. or 5 times 1/5, that would equal 1, or 1/10 times 10. So do you start to see the pattern here? A and C are reciprocals. A times C equals 1, so A and C must be reciprocals of each other. Actually, you could see that here too. If you just solved this for A by dividing both sides by C, you'd get A equals 1 over C. Oh look, they're reciprocals. Now, we're going to talk more about these other statements that they told us, but just for a second, look at the answers. The first one is A equals 0 or C equals 0. That actually can't be true. No matter what, that can't be true, because if A equals 0, well, the reciprocal of 0 would be undefined. It can't happen, because you can't divide by 0. C couldn't be 0, because then you'd have 1 divided by 0. So A is definitely out of the question, option A. All right, back to the statements. They tell us B plus C over D is undefined. Again, it seems like that doesn't tell us anything because it tells us it's undefined. But that is actually a clue. If you have a fraction and it's undefined, that means you must be dividing by 0. That's the only thing about a fraction that could make it be undefined. That must mean that D equals 0. For sure, that's true. They actually told us that. It's just kind of hidden in the statement. So looking through our options, maybe it says D equals 0. It does say B equals 0, but nothing about D. So let's go back to the statements. We know that A and C are reciprocals. We know D equals 0. What does this last thing tell us? Well, actually, wait. We know D equals 0. So instead of just saying A, B, C equals D, let's say A, B, C equals 0. So 3 things are being multiplied together, and they equal 0, right? A and B and C. So here's the thing. When you multiply things together and they equal 0, the only way for that to happen is one or more of the things must be 0. That's actually the zero product property. The only way you can ever multiply things together and equal 0 is one of the things you're multiplying has to be 0. Well, we already said A and C couldn't be 0. That's impossible. So it must mean B equals 0. Remember up here, A and C could not be 0. So B equals 0, and that has to be true. So the answer is D. 58 says a cosine function is shown in the standard xy coordinate plane below. One of the following equations represents this function. Which one? All right, now there's at least 2 different ways to approach this problem. I'm going to start by assuming you haven't learned anything about cosine or graphing cosine functions in class, and you're just trying to figure out this problem. One thing you can do in a situation like this, and it doesn't have anything to do with cosine specifically, just they give you a graph and an equation, is try and pick off some points from the graph and plug them into your equation and see if they're true. So this point has an x value of 0, and the y value is 1, 2, looks like 3. And then we have a point down here, the x value is pi over 2, and the y value is 1, 2, negative 3. And I mean, we have this point here, it's just I don't know the x value there. But this tick mark is pi over 2, in other words, half of pi. And that's probably another half of pi, so this would be pi over here. So what's right in between 1/2 and 1 pi? Well, 3 pi over 4, or 3/4, right? What's right between 1/2 and 1? 3/4. So what's right between pi over 2 and pi? 3/4 pi. So there's that point, 3 pi over 4, comma 0, the y value is 0. And then there's this one, the last one is pi, the x value is pi, and the y value is 3 again. All right, so I'll demonstrate plugging a point in just so you see what that would look like. We'll try this equation here for f. So y equals 2 times the cosine of, I'm going to plug in this x value pi. Now when you use your calculator, make sure you're in radian mode because pi is a radian measurement. We're not using degrees here, we're using radians. So that's one thing to be on the lookout for. If you type cosine of pi over 3 into your calculator, you should get 1/2. So 2 times 1/2 or 2 times 0.5 is 1. That's the y value. Is that the correct y value? No, we were supposed to get 3. So it can't be this equation because we plugged in one of the points and the x and the y values didn't match up. Basically, it didn't give us a true statement. If I plugged in the corresponding y value, up here we would have gotten 3 equals 1, and that's not true. Now you could do that with all of these equations until you get an equation that works. Now the equation technically has to work for all of the points on the graph, so don't just plug in one point and see that it works and get excited and choose that. You need to show that all of the points work. So that is going to take some time, and that's because, again, I'm assuming you haven't learned about this in class. If you have learned about it in class, what you want to remember is that a value, or the number that goes in front of the equation, tells you the amplitude, or in other words, how tall the cosine graph is going to get. Well, this cosine gets up to 3 and -3, so the amplitude is 3. So we can rule out g. And the other thing to remember is that the cosine wave normally starts here at 0 and then ends at 2 pi. That's how long it takes for the wave to go from the top to the bottom and then back to the top again. But this one starts here at 0, dips all the way down, and then comes back up again just in the time of pi. It doesn't take 2 pi, it takes just pi. So here's our original graph. It's normally this big, but the one that we have in this problem is only half as big. Looks like that. Basically, it went through one full waveform in half the time. And that comes from having a b value of 2. In other words, a horizontal compression of 2. So the answer is K. Another option you have, and I'm not demonstrating this in the video, but you could just graph these on your graphing calculator and see which one matches this picture. Just be careful with that because the tick marks on this graph are going up in terms of pi, not like 1 or 2. And again, you need to make sure your calculator's in radian mode if you're going to type these kinds of things in and look at this kind of graph. 59 says, the figure below shows a flying kite. At a certain moment, the kite string forms an angle of elevation of 75 degrees from point A on the ground. At the same moment, the angle of elevation of the kite at point B, 240 feet from A on level ground, is 45 degrees. What is the length in feet of the string? So that's a little bit confusing to read all that. Luckily for us, all the information they tell us is also provided in the diagram. So the things we know in this picture are this angle, 75 degrees. We know this side length is 240, and this angle is 45. In geometry terms, that's angle, side, angle. One of the key things to note about this problem is that we don't have a right triangle, so we can't use right triangle trig. We can't just use regular like SOHCAHTOA, sine, cosine, and tangent. 75 degrees plus 45 degrees is 120 degrees. And all three angles in a triangle should add up to 180. So that means that this last one is 60. 180 minus 120 is 60. So again, it's not a right triangle. But the information they give us does fall under this angle, side, angle category. And that's because specifically this information is in this order. We start with the angle over here, and then we travel through the side, and then get to the other angle over here. So angle, side, angle. And that tells us that we need to use law of sines. Unfortunately, that's really the only way to do this problem, so if you're not familiar with law of sines, there's really not much you can do. Now the problem is asking us for how long the string is, which is over here in purple, and that's across from angle B, so I'm going to call that side B. And the law of sines says we can put a side over its angle, sine of its angle, and we could do that for another pair of side and angles. Well, we know this side length down here, and that's across from this angle, which you also know. So I could put 240 over the sine of 60. And while I'm filling in values, for angle B I could put 45. Alright, so the sine of 45 degrees is the square root of 2 over 2, and the sine of 60 degrees is the square root of 3 over 2. These are just our regular values from trig, which again you kind of need to be familiar with from class. And now I'm just going to cross multiply. So we have square root of 3 over 2b equals the square root of 2 over 2 times 240. And the 2 and the 240 can simplify to just be 120. So now I have the square root of 3 over 2b equals 120 square roots of 2. And really I'm just trying to solve this for b. So I'm going to divide both sides by the square root of 3 over 2. That gets rid of that. So b equals, and we may want to rethink this thing over here. 120 square roots of 2 divided by this fraction is the same thing as times the reciprocal. So we have 120 times 2, which is 240, and then square root of 2 is still on top, and the square root of 3 was on bottom. Now the problem is this answer doesn't match any of the ones given. And that's because the ACT usually doesn't provide answers with a radical in the denominator. The easy way to get rid of that is just to multiply it out of the denominator. And what happens then is on top we have the square root of 2 times the square root of 3, which is the square root of 6. So 240 times the square root of 6 over, and then on the bottom, the square root of 3 times the square root of 3 is basically the square root of 3 squared, and those go away, so we just get 3. Now 240 over 3 is 80, so we have 80 square roots of 6. So the answer is B. Now some calculators are capable of doing this kind of work with all these fractions and square roots and giving you exact values. A lot of calculators just spit out decimals, so that's why I wanted to show you how to work through this by hand. Number 60 says, if a publisher charges $15 for the first copy of a book that is ordered and $12 for each additional copy, which of the following expressions represents the cost of Y books? So one thing we can recognize about this problem is it's basically following a linear pattern. It says there's a $15 charge for the first copy, that's a starting value or a starting point, and then it's $12 for each additional copy. The $12 each sounds kind of like a slope to me, or a rate of change. So this is definitely linear, and so my first thought is I'm looking for like mx plus b. That's the first thought that comes to mind. Now it's confusing because there's a bunch of y's in this problem. We're using y as our variable instead of x, but that's okay, we can kind of ignore that. We're looking for a starting point and a slope. Now this problem is a little misleading because it seems like $15 is our starting point, and so we should choose G. There's our $15 starting point, here's our $12 slope, or $12 for each additional copy. Seems like the answer should be G. But let's just test out this situation. If I were to make like a table, and over here is the number of books, so let's say I order 1 book, well I know that that should cost $15, based on what the problem says. If I order 2 books, so I'm starting with $15, and there's a $12 additional cost for every book, so 15 plus 12 would be 27. If I order a 3rd book, that should cost me another $12, so 39. And let's just see if that works over here, because we're thinking our answer is G. If I plugged in 1 for buying 1 book for Y, 12 times 1 is 12, plus 15 is 27. So this is saying that 1 book costs $27. That's not true, it should only cost $15. So this problem is a little misleading because they say $15 for the first copy. They're not lying to you, it is $15 for the first copy, but if we're thinking about this form, mx plus b, remember b is your starting point, meaning like your 0 term or your y-intercept. That should be the cost of buying 0 books, which doesn't really make sense in this problem. But if I were to work backwards by subtracting $12, that would say that 0 books cost $3. Again, that doesn't really make sense. Think of it as maybe shipping or something. But 0 books should cost $3. My b value, or my starting point, is actually 3. Not negative 3, so we can rule out h. We already know g is wrong. So we're looking at either f or j, and we know that the slope of each additional book is $12. Let's just say that the answer is f and then test it out. So if I plug 1 in for y, 12 times 1 is 12, plus 3 is 15. That works. If I plug in, let's say, 3 for the y value, 12 times 3 is 36, plus 3 is 39, and that works. So the answer must be F.